Hello, ladies and gentlemen. Thank you for joining the meeting today. My name is Alan Pan, and I am the Deputy CEO of Model 3D. The topic I would like to share with you is the digital twin-driven T0 production for injection molding. This is the outline of today's presentation. The first one is the introduction of T0 production. The second is to illustrate the inside of Model 3D digital twin-driven T0 production. The third part is about customer success stories. The last one is the summary of today's presentation. A digital twin is a digital representation of the physical object or system. The twin concept was used by the NASA in the late 1950s during the Apollo mission and was developed further to digital twin in 2011. Apollo mission is the first success story of digital twin. Now, digital twin technology has moved beyond manufacturing and into the emerging worlds of the Internet of Things, artificial intelligence, and CA simulation. There is a saying in the mechanical engineering world that really captures the gap between design and manufacturing. Anybody can design it. Few people can make it. There are many gaps between design and manufacturing, including domain knowledge difference, responsibility difference, and so on. Part designers are focused on meeting a client's needs. For example, how big and how thick of the part. Designers are challenged with available materials and cost constraints. Their priorities are meeting client needs within a timeframe and a cost structure. The manufacturing team has the opposite perspective. They are less concerned with the product and how it fits the client needs, and more concerned with being able to produce it in a timely manner. Concerns of the manufacturer start with sourcing materials and optimizing the asset of plant, the equipment, materials, and people to produce the most product with their available resources. Their goal is to get the product out the door on time. Basically, they belong to different worlds with different domain knowledges. However, in today's very competitive global economy, it is increasingly difficult to stand out from the competition. Achieving these goals requires the coordinated effort of all those involved in the product development, from concept to delivery. Processes must be streamlined to eliminate the hiccups that often occur when designs are passing from one phase to the next. So, now, how to reduce gaps between design and manufacturing is the most important topic. In order to bridge gaps between simulation and physical world, a digital twin-based simulation is proposed and viewed by converting the whole physical assets and system, including by the process of injection molding, into a model, in which the process is from design to production. Not like a traditional CA simulation, data measured through various sensors attached to the actual assets are transmitted to the CA simulation as analysis conditions, such as dynamic operational responses come from actual machine. This slide shows the whole picture of the digital twin-driven simulation solution for injection molding. The meaning of the T0 is the first shot success, which is the more first tryout achieved the criteria of production. Our vision is that the results of the Model 3 simulation can be able directly applied on the shop floor without extra design change, mode modification, and process parameters adjustment. The digital twin system is mainly composed by 5 twins, including part and mold design, material, machinery, and molding process. The part and mold design digital twin come from design data. The material digital twin means material physical properties generated by material measurement experiments. The molding process digital twin means various process types, such as bi-injection, compression molding, and so on. In terms of machine digital twin, many people misunderstand that the performance of the production machine of the same brand and model will be exactly the same. But it is not true. Actually, each machine is unique. The characteristics of the machine are affected by many factors, such as environmental differences, and further cause gaps between simulation and real shot. Machine digital twin will be the focus of today's presentation in later slides. I will further talk how Model 3D creates a machine digital twin through machine characterization services. So the CAE simulation can consider the unique performance and dynamic response of each machine, and process conditions generated by Model 3D simulation will be able directly applied on the shop floor to dramatically reduce the time and cost of the actual mold tryout. What is design digital twin? The part and mold design digital twins are based on design data. Simply speaking, we will try to completely clone design data into CAE world. The purpose of our design digital twin is to help designers make their design better for manufacturing, such as DFN analysis, design automation, and design optimization. We are not only transfer the design data from CAD to CAE, but also optimize the design solutions by leveraging upfront CAE simulation. For example, this slide shows the get wizard of Model 3D, which help users to quickly generate high-resolution mesh for better CAE simulation. This slide shows the cooling channel wizard of Model 3D, which help users to quickly generate various channel layout for evaluating cooling efficiency. What is process digital twin? The molding process digital twin means various process types with the best-in-class 3D analysis technology. Model 3D can help you simulate the widest application range of molding processes to optimize product design and manufacturability, such as typical injection molding, bi-injection, PU forming, powder injection molding, conformal cooling, fiber reinforced material, and so on. For example, fiber analysis. We not only transfer the material parameters of fiber composite material into simulation, but also develop a thorough patent-protected methodology to allow users to get more accurate and detailed simulations of 3D fiber orientation, which helps users control anisotropic shrinkage for fiber reinforced parts. Mechanical properties due to fiber orientation can also be visualized and analyzed for warpage prediction. With its accurate fiber orientation and anisotropic shrinkage predictions, users can achieve warpage control, cost reduction, and strength improvement. Compression molding is a process in which a molding polymer, called charge of a compound, is squeezed into a preheated mold cavity under heat and pressure until the charge has cooled. Compression molding enables the production of compressed composite compound at a fast rate. Model 3D supports many discontinued FRP materials that frequently used in the compression molding, including thermoplastic material, GMT, LFTG, or LFTD. Let's talk about material digital twin. Rheological behavior is one of the most complex and important properties in polymer processing. To get the reliable results of the process simulation, reliable material data and models are necessary. The purpose of the material digital twin is to help users to create reliable material data for simulation through professional material measurement experiments. In order to help Model 3D users building their proprietary material database, we have set up our own material research lab for more than 20 years. Currently, our lab already passed the ISO 17025 and provides various material characterization services for both thermoplastic and thermoset, such as material property measurement for viscosity, PVT, CP, K, curing kinetics, and so on. Okay, let's talk about machine digital twin. An injection molding machine consists of several parts. Injection unit, the mold, the heart of the whole process. Clamping injector unit, control panel, and so on. Actually, every machine is an independent individual. Even if same brand and model, the accurate differences of each machine will make its own characteristics. Therefore, our machine digital twin is to try to transfer important physical assets and dynamic responses data of machine into CAE to bridge gaps between simulation and real world. Another keys for machine digital twins are control panel and operational dynamics response of actual machine. Now, Model 3D already supports control panel UI of machine for many brands. Let's see a difference of injection speed between ideal setting and real response. Like this figure, people will set a single stage value of injection speed in many cases. However, will real reaction of machine always follow the setting value? Actually, every machine has its own unique behavior. We represent different real response. A is an electric type injection machine. His real response is quite close to ideal setting, only small gap in the beginning stage. But B machine is not like A. The real speed profile in the beginning is much far from ideal setting. In terms of the machine C, not only gaps happen in the beginning stage, but also speed is over setting value a lot in the last stage. Actually, different responses might affect the plastic flow behavior seriously. If we check the fitting pattern over different machines on same timing, the field volume of the A is larger than B and C. So that's why even each machine has same mold design, part design, plastic material, and same process condition. But final part quality might be quite different on different machines. Regarding to CAE simulation, how big difference between simulation and real molding response? Basically, process conditions of CAE are based on setting value of machine control panel. If the setting value is ideally, CAE simulation result will be ideally. If the setting follow practical situation, the CAE simulation might be more close to real shot. Like this example, the injection speed of CAE will follow the setting. However, the setting value is different from the real response. So, the pressure curve of CAE simulation will be far from the reality. Since the injection molding machine is affected by many factors such as machining, materials, and controller, machine characterization is particularly important. If somehow we can make CAE simulation based on the real machine responses, the gap between virtual simulation and reality will be improved. How to make it? The new approach, real reaction CAE, we copy the real response data of the injection molding machine into the virtual space of simulation. And then CAE simulation will reflect the behavior of a real production by considering real response data. Not like the traditional CAE follow the setting profile. Real reaction CAE will follow the actual response curve of the molding machine. Model 3D machine digital twin is to collect and analyze the fundamental characteristics and molding responses of the machine, and then construct a digital clone model of the molding machine into virtual CAE space, and enable the CAE analysis performing design optimization by considering real molding response of the machine. Simply speaking, we would like to make consistent heartbeat between simulation and real shot. What is modeling process of Model 3 machine digital twin? The workflow starts from injection molding machine. We will arrange a series of experiments to catch machine response data, and then the data will be transferred to modeling solver for data analysis and model generation. After data analysis and model generation, there are two parts will be delivered to users. The first one is machine response analysis report, which help users to further understand the actual status of the machine. The second is the digital twin model file, which will be exported to Model 3D machine database for simulation. And then, applying the data in Model 3D analysis, Model 3 solver will be run simulation according to the actual machine response data automatically, making the simulation result more consistent with real shot. This slide shows how to access machine digital twin model in Model 3D. It's very easy. The first step is to import digital twin model on machine wizard interface. The second step is to select the right machine on process wizard interface, and then run Model 3D analysis as usual. That's it. Okay, let's talk about 3 case studies. The first one is the basic validation, and second and third cases are customer success stories. The case for basic validation is based on the Arbor machine. The information of machine is listed here. The machine is hydraulic type. The part is a cover with 1.58 mm thickness. The material is PS from Qimei. This slide shows the comparison between simulation and real shot. Traditional simulation is same as before. The profile of the flow rate follows the setting of a control panel. However, the result of the digital twin based simulation follow the behavior or real model. The response curve of simulation is high matchable with real shot. This slide shows the comparison for speed and pressure between simulation and real shot. The response curve of either speed or pressure from simulation are quite matchable with real shot. Based on the comparison results in this slide and previous slide, we can say it proves that the digital twin model approach is workable. The second part is the case study from customer. This customer is CM Technology from Suzhou, mainland China. CM Technologies belong to group of the Opel Lighting, which is an industry leader in lighting industry. CM Technology business scope of the product and model development mainly includes general lighting, consumer electronics, automotive, packaging, and medical devices. The target of the project was to make first shot success. Someone would say it is T0 production. In order to achieve this target, the scope of the project included several parts described in this slide, including Model 3 software implementation for digital twin of the part design and model design, material characterization, machine characterization, annex, MES system integration, and so on. Especially for the implementation of digital twin-based CAE, CM Technology invests many resources to build fundamentally infrastructure and data, including one new in-house material research lab. This slide shows the application scenario of the machine digital twin at their factory. Every simulation we consider machine digital twin. And after simulation, process condition will be exported as the input condition of the real injection molding machine. In this case, the process condition from machine setting for success shot has 90% measurable with condition provided by CAE simulation. This slide shows the filling pattern comparison between simulation and real shot. Based on the process condition generated by the digital twin approach, there are highly measurable patterns between simulation and real shot. Actually, this project helped CM Technology reach its very big achievement on business development of the company. This slide shows some key results of the fiscal year 2018. There were 652 modes developed in 2018, and 384 modes reached first shot success. Success rate is over 50%. It's really amazing. Furthermore, the turnover of the company grows 108% with 70 employees only. The third case is from Taiwanese company, Jumro Plastic Tech Corporation Limited. This company is the second-tier supplier of automotive OEM, such as supply chain of Yamaha Motors. This project was started from 2020. The long-term target of the project is the same as the project we have initiated with CM Technology. Customers would like to reach first-shot success for every mode they developed in the future. But everything in the world starts small and then becomes bigger. Therefore, in the beginning stage, customers selected a production mode for creating first success pattern of the digital twin application. This slide shows the information of the first case. It's a battery cover of a scooter. Material is PP. The injection molding machine is Taiwanese brand. This slide shows the comparison of injection speed and pressure between simulation and real shot. The response curves of either speed or pressure from simulation are quite matchable with real shots. In terms of process conditions, the process conditions from machine setting for success shot has 100% matchable with conditions provided by CAE simulation. Customers told us that they tried to adapt the same process condition from CAE simulation for first mold trial. And amazing, the first mold trial had met the requirement of the production. This slide shows the filling pattern comparison between simulation and real shot. Based on process conditions generated by digital twin approach, there are highly matchable patterns between simulation and real shot. Summary. Under the trend of smart manufacturing, digital transformation is an important issue to be faced. If the organization can successfully adapt digital twin technology to achieve the integration of virtual and real, coupled with the use of the scientific trial model to replace traditional trial model, then it can greatly shorten product development time and accelerate enterprises to enter a new era of the smart manufacturing and toward first-shot success production. Model 3D machine characterization service plays an important role to achieve first-shot success for smart manufacturing. This service will bridge the gap between simulation and production to allow the scenarios of simulation considering physical characteristics and dynamic responses of actual molding machine. Through this solution, optimized process conditions generated by Model 3 simulation will be able directly applied on shop floor to dramatically reduce the time and cost of actual mold trial. Thank you for your time and attention. Have a nice day.